Okay, so today we are playing the Reentry, an orbital simulator game. We are going to do the Academy lesson for the project Gemini, and this spacecraft was what is considered like the bridge to get to the moon between the Mercury and the Apollo program. And we are going to do the electricity session, where the spacecraft is configured in the same way as the Gemini 8s and upwards.
Roger, staging.
Okay, so it seems like we're already in orbit. The capsule is powered by two systems. The primary power source is from the two fuel cells to generate power from hydrogen and oxygen. The secondary system is powered by four silver zinc batteries. The fuel cells are installed in the adapter section of the spaceship, while the batteries are in the capsule. The fuel cell is using a system called a reactant supply system that supplies cryogenic oxygen and hydrogen to the fuel cells. The ionization of these substances produces electricity and water. The amount of reactant consumed is directly related to the power load on the fuel cells. Two fuel cells are capable of running the spaceship alone, but since they are located in the adapter, it will be separated before the retrograde burn. So that means that we will operate without fuel cells after we are doing the retrograde, and just using the batteries while doing the re-entry into the atmosphere. From the retrograde burn to re-entry, the batteries will be used. The power sources can be configured using switches on the right panel in front of the co-pilot. So here we have that. There are two fuel cells installed. These are named Fuel Cell Section 1 and Fuel Cell Section 2. So there we have these. Each of the fuel cells have three power stacks, A, B, and C. You can turn each stack inside each fuel cell on and off in case of malfunction, however these are all typically on throughout the flight. Using the fuel cell stack gauges 1A to 2C, you can immediately see the load on each stack. So where are we at then? Oh, sorry. These? Oh. Using the voltmeter, you can see the volts on each stack as well. If this is low on one of the stacks, you should shut it down in danger of fire or explosion. So I guess here we can cycle through different fuel cells. Yeah. Stack 1B. The voltmeter will now display the state of the stack. It is important to include checking these as part of your monitoring routine. As mentioned earlier, the fuel cells are consuming cryogenic reactant. You can use the cryo gauge to monitor the RSS. It can be found in the middle section of the panel. Let's see. Switch to commander seat. Okay. It is off by default, so turn the cryo selection knob below it to A2 to see the status of the hydrogen cryo supply. Okay, so H2s we have full quantity of hydrogen and full quantity of oxygen as well, but a little bit higher pressure. That makes sense. Cryogenic system as a whole is involved in deep topic, please refer to the Gemini flight manual for more details. And I have that on a separate screen here, which is not shown in this video. The other power source are batteries. There are 4 batteries installed in capsule. These can be turned on or off on the right side panel of the pilot seat, like we learned in lesson 1. So we have those down here. I'm actually going to turn all of those on now. Both these power sources are powered to the main DC bus, where most of the electrical components in the spaceship are connected to. It is normal to have both power sources connected to the main DC bus during launch and ascent. When inserted into an orbit, the batteries are usually turned off, leaving both fuel cells on. Okay, I guess I should turn them off again. Another electrical power source exists. This is an isolated system that provides power to the power technical system for use for separation and jettison. The system is powered by 3 silver zinc batteries named squid batteries. Those are these 3. Yeah, they're also turned on. These are connected to a common control bus. They are usually on for the entire mission. There are a few switches used to arm the squibs, like boost insert squibs that will be turned on before launch. And those we have over here. Another is the landing squib. The landing squibs are used for reentry, and the retro squibs are used for retrograde burn. It is important to disarm the squibs that are not in use at all times to prevent accidents. These are all in the safe mode. Each main battery has a test switch. These can be used to test the batteries. Using the DC voltmeter selector, you can set it to battery test. And then now I double clicked. Let's see, going to the pilot seat, and we should have these. Never mind. Squid. Okay. I'm quite certain that these are the additional ones. One is 28 volts and 28 volts. Okay. If the square battery should fail, you can use the bus tie switches to connect the main bus to the common control bus. It is easy to forget that the batteries need to be turned on again before adapter separation. BTRI power telelight on the center panel will illuminate to remind you of this. Perfect. Oh yeah, that's this one over here. Okay, that is enough now. Please refer to the manual for more details. Okay, that's it.